and we're going to look at the thrust plate as well. So the thrust plate sits essentially here at the bottom of the motor mount, and then that is what transfers all that thrust from the motor into the walls of the rocket. And the walls of the rocket are the ones that essentially take all of the load. So all that load, getting back to rocketry 101, it all comes back to Newton's third law, which is every action has an equal and opposite reaction. So essentially we're forcing, so we've got thrust coming out, we've got hot gases coming out of the motor this way, which is generating thrust this way. And all that thrust is loaded up on the outside tube, all that force. And it's done that through this thrust plate, essentially. So we're going to look at that as well and make sure the thrust plate is going to handle that, that load. Yes, essentially it's the outer, so it's the outer body that takes all the weight. That basically puts it all together. Grab let me grab Labrat. Labrat's what I'm going to put the next flight out of Wayland. That's what I'm going to put MC Sat 1 up on. So essentially, the motor goes in there, and then it's retained by this particular unit, and then this is where all the forces are generated. So the motor's pushing out the hot gas that way, which is generating the force this way, and that's essentially transferring all the force to the outside tube, and that's what we're looking at. And we need to do just quickly while I've got Labrat here, we need to do things like fillet the fins just to give them more strength and make sure that they can handle all that force. So it's going up at a particular force. There's a bunch of stuff on there. Cool. So let's go shopping for a thrust plate. See if we can find. So essentially, as you can see, this is basically just a joiner between that internal. So going back to Labrat this week, sorry. So this is just the joiner between the motor mount tube. So again, I'll just take that off for a sec. So all that force is getting pushed onto that motor mount by the retainer, which just holds it there, and then that all gets transferred across to the body tube, and essentially all the force is in the body tube as it's going up. So you can see all the retainer is just basically a circle that basically moves all that force from that internal tube onto the body tube. So we got an 8-inch. I don't even know if we can get an 8-inch thrust plate from. These are. What's the company name? 8-inch 98 thrust plate. That's the one we want because we're going to do a 98 mil. Perfect. Right, so what this does, so we screw it onto the motor mount tube. So you can see, and again here, there's a tube inside here that's used to mount the motor on it. So if I go over to the design, you'll see here there's a tube here where there's a motor mount. What I don't have on there is the thrust plate. It's actually not on my design, I just realized. Let's go and add that in. Do you have a thrust plate? Used to have a thrust plate, didn't you? Alright, I'll add another. What have we got there? I'm going to add another centering ring. I'm going to call it thrust plate. this live sessions as well. These are just a bit of practice for me as well, just to get up and going. Finally worked out. So I'm not sure if you saw the one last night with me trying to do. So I'm going to build a rocket factory in the SMP, and I had one of the guys come along and give me a hand there. I didn't have the video, which basically was because I didn't have the layers in the correct order. I figured that out this morning, so I'm using these videos just to get a better understanding on how to live stream as well. So hopefully you be a little bit patient with me on those. Right, so we've got thrust plate. Thickness is going to be, how thick are they? Oh, here's a good picture of it here. So you've got the retainer. The retainer goes onto the thrust plate, and the thrust plate is what pushes all of that thrust onto that outside of the tube. So hopefully that makes sense. Inner diameter, inner, outer. Orange 8-inch, yeah. Oh yeah, we've got that. How thick is it? How thick are you? Aeropack, that's the name of the company I was trying to think of. These are Aeropack thrust plates, I believe. Doesn't tell me how thick. I'm going to go with 3 millimeters. It does weigh 603 grams, so I'll overwrite the thing. So we've got 199, 102. That's perfect. 603 mass. If you watch down here, when I adjust that, you'll see the center of mass moves backwards. That's because we're adding more weight to the back. And I think that's lined up correctly. So let me just play with that. Yep, that's good. 0. That was crazy. 0. 0 is perfect. And we want aluminium. Or aluminum for those that are on the other side of the world. That all looks good. Cool. So I've now added the thrust plate. So the thrust plate will take all of that. So essentially in this rocket, I've actually just used the centering ring here, which is what's used to center the rocket, because this doesn't feel as much thrust. It'll handle it. And this inside there's an epoxy ring and another fillet, like I was talking before. That's is what's taking all the weight. What we want to do with the thrust plate is take it and have the thrust plate sit over the tube, so that when it's pushing on it, all of that power goes into the tube, and there's no other material that would be able to fail in between. So you don't have like an epoxy fillet that'll need to handle that level of pressure at that point. So, alrighty, which means I've probably got my size wrong on that. I need the outside of the body tube. The outside is 203. That's right. So the outer diameter is that. Yay, cool. So essentially all of the weight, all of the thrust comes out of the motor. So comes out of the motor. All that thrust then gets transferred through that plate. Now I'm pretty sure that plate can handle the amount of thrust that we've got, but let's just triple check. Do they have the numbers? Actually, that looks like a 4 mil thickness. Designed to handle loads in excess of 1,000 pounds. while still providing a safety factor of 4. So this is saying, so same material, looks like it's the same, yeah, everything's going to be the same. So he's calculated 4,448, so I'm happy with that. I'll do a bit more research later to see. But essentially that means we can use, let me create a new tab. We're going to design. We're going to add a thrust plate, which is one of these. Just grab that URL. And yeah, it's weird, I know, having the multiple different dimensions. This is one of those weirdnesses inside of rocketry. Most dimensions are talked about in Imperial, except for a few, and those few, one of those few is the motor mount tube. The size of the motor mount is, I don't know why someone's decided that that we're going to talk about it in millimeters instead of inches, which is a good thing. Anyway, that's that plate, 3 millimeters thick, can handle thrust. So again, so that's a that'll be a safety factor of 2. So it's double the thrust that this particular motor can generate. So this can do 2,500. So it should be able to handle it.